Hey everyone, Keegan here from Taurine Technology. If you've ever tried to set up a software-defined network, you know it can be a nightmare of command lines, complex configurations, and sparse documentation. What if we could change that? What if we could make advanced networking radically simple? Today I'm going to show you how to use SDN Launch Control to build this exact network. We'll turn a simple Raspberry Pi into an intelligent, enterprise-grade switch and manage the entire thing from a clean web interface. No deep networking knowledge required. Before we dive in, let's quickly go over what you'll need. First, your hardware. A Raspberry Pi 4, a couple of USB to Ethernet adapters, an access point, and a server running Ubuntu to host Launch Control. You also need Docker installed on your server. All the links to what you may require can be found in the pinned comment of this video. Okay, let's get started. Step 1. Configure the Pi. First up, we need to prepare our Raspberry Pi. We're going to use a custom Ubuntu image that comes with all the necessary software pre-installed to save us a ton of time. You can download this from our GitHub. Once it's downloaded, open up Raspberry Pi Imager and select Use Custom, and choose the image file you downloaded. Don't forget to set your username and password and enable SSH in advanced options. Once this is done, we'll write it to the SD card. Once this process is complete, remove your SD card from your computer and put it into your Pi and power it on. Give it a few minutes to boot for the first time. Once it's online, SSH into it and run a quick sudo apt update and sudo apt upgrade, just to make sure everything is fresh. Once that's done, reboot the Pi. And that's it. Our Pi is ready to become a switch. Step 2. Install Launch Control. Now for the brains of the operation. On your server, clone the Launch Control repo from GitHub. Make sure you check out the correct version. This contains the code for both the backend and the frontend. We'll start with setting up the backend. After cloning, navigate into the backend directory and create an env file using the commands from the README. This file holds all your configuration variables. It's important to change your username and password fields as well as the Telegram API key. You can generate your own key on the Telegram website. I'll leave a link down below. With the configuration done, all we have to do is run the automated setup script within the backend directory. It will ask you to confirm your environment variables and then build the Docker containers for you. This may take some time. Once our backend is running, we'll create an env.local file. Make sure to replace the placeholder IP addresses with your server's actual IP address. With this configuration also complete, all we have to do is run the automated setup script for our front-end. It will ask you to confirm your environment variables and then build the front-end Docker container. This may take a few minutes, so we'll speed this up. Once this is done, you can navigate to the UI by going to the IP address of your server on port 3000. And that's it. We're done. Step 3. Physical setup. Okay, so now that the software is running, time to plug everything in. Your Pi should be connected to your network using the built-in Ethernet port. Plug your USB adapters in so that the top one will go to the network and the bottom one will connect to your access point. Step 4. Switch configuration. Now for the magic. Open your browser and navigate to the Launch Control UI. We'll go to the switches page and now add the new switch. Just fill in its name, IP address, login details, and the URL of your API. This will be the IP address of your server followed by port 8000. Launch Control will now connect to the device and install Open vSwitch. A system monitoring tool will also be installed so we can monitor the CPU, RAM, and hard drive usage of the switch. Once this is done, we can navigate to the switch page and see the system stats coming through. The next step is to install an SDN controller. This will also run on your server, but you can run it on a separate host if you wish. Navigate to the controllers page and click on the Install Controller button. Here you will provide the login details for the server you are running Launch Control on. Finally, we'll create an OVS bridge. This is what connects our ports together. We'll add our two USB adapter ports, but it's crucial that we don't add the main ETH0 port, as that's our management connection. You can identify the adapters by looking at the ports starting with ENX. Assign the controller we set up in the last step, and that's it. This process is quite lengthy, but it will set up your SDN bridge and install a range of network utility scripts to enable advanced network monitoring. Once this is done, we'll be able to see our port statistics on the switch page. And there we have it. If we navigate to the dashboard, we can see our network map, live and online. You should be able to connect to your access point now and access the internet. Our next step is enabling the AI features so we can start to monitor traffic and apply shaping rules. Navigate to the plugins page and install the Open Daylight Traffic Classification plugin, and then install the Traffic Classification Sniffer on the SDN switch we set up. Remember to insert the correct API URL, which is the IP address of the server, followed by port 8000. Selecting the ports is very important here. We have set up our device so that port 2 will be connecting to the access point and port 1 will connect to the network. This means we want to select port 2 as our client and monitoring port and port 1 as our WAN port. This process will install all the requirements to start using AI to monitor and manage traffic in your network. Once these are enabled and installed, we can navigate to the monitoring section and view real-time traffic classifications if we have devices accessing the internet on the network. If we go look at the model we are using for traffic classification, you can see the number of categories of traffic it was trained on, read about the model, and see other generic information. This is simply a demo model, but if you want a custom model or to test other models, feel free to reach out to me. Under our AI Services tab, we can also see the AI Traffic Classification plugin. On this page, we can create meters. A meter is simply a traffic shaping rule that we can assign categories to and a rate limit. We can also assign devices to a meter. We can view all the devices in our network by going to the device overview page. I know the IP address of my phone, so I'm going to label my phone to make it easier to find. When I go back to create a meter, I will assign it to my phone and also assign an activation time to the meter. As you can see, it's really easy to create complex rules with Launch Control. Once we have assigned meters to traffic classes, we'll be able to see how much data is used for each category of traffic and for each device in the network. Navigate to the Monitoring tab to find detailed network statistics for users and categories of traffic. To end off our demo, I want to show you how to set up Telegram notifications. You can receive summaries of data usage in your network, such as the top data users, top traffic categories by flow count, or data usage, as well as notifications when a category or person has consumed data above a threshold limit you have set. Simply navigate to your profile, then the Settings tab, and click Link Telegram Account. Scan the QR code with your phone, click Start, and you'll receive a message when your account is linked. Once it's linked, navigate to the notifications page and set up your desired notifications. And just like that, we've built a fully functional, intelligent SDN using affordable hardware and open source software. This is about more than just cool tech. It's about making powerful tools accessible to everyone. Thanks for watching. You can find all the links to the documentation and GitHub repos in the description and pinned comment below. Feel free to reach out to me using the email on screen.